Hello everyone, welcome to this lecture video. Uh, in the operating system, we are in process scheduling and synchronization. We going to cover deadlock methods and what is deadlock characteristics and how we can handle the deadlocks and how will you prevent the deadlocks. So in this lecture video, we have start with what is deadlock. Before starting, we have to know what is process, what is resources. We already discussed in the previous lecture video. So here, what is deadlock? Deadlock is a situation where set of processes are blocked because each process is holding a resources and waiting for another resources. It's acquired by some other process. Uh, for example, process P1 here, resource R1 here. R1 will be allocated to the process P1. Then resource 2 is waiting for process P1. It is resource 2 is allocated to process 2. So then resource 1 is waiting for process 2 is waiting getting request from R1. So this kind of situation creates a deadlock. So deadlock situation where a set of processes are blocked because each process is holding a resources and waiting for another resource acquired by some other process. So this is a deadlock introduction. uh, we can have the real-time example of deadlocks. There are two trains are traveling on a different tracks. If a crossing came, a train must hold or wait for some time to continue the journey. That waiting situation is referred to as deadlock here. So in this picture, we can able to see the same single track. The both the train coming at the same time. It will occurs the deadlock because no one can go in the proper scheduled time. So while playing a chess, a checkmate is a deadlock situation where there are no chance of escaping and have to hold for some time to move. So this checkmate, we give an example for deadlock. So the same situation in the database, we have deadlock situation database also have process A, process B, resource X, and resource X will be sending the allocated to the process B, and resource Y will be allocated to the process A. So in this now the two transactions take place at the same time in the database. So it holds only one at a time. So this causes a deadlock situation. In this case, we can get the deadlock situation will be a uh, this situation can be called as a deadlock here in the same database system. So condition for deadlock, we are talking about the deadlock. There are four conditions that process undergo deadlock situation. How we can identify that process in a deadlock situation? There are let's have the condition. There are how we can identify the process, regular process in a deadlock situation. We have to follow the certain conditions. We have to see the what are the conditions for deadlock. First one is a mutual exclusion and hold and wait, no preemption and circular wait. These are the main condition for deadlock in operating system. Then start with the mutual exclusion. When a process is accessing a shared variable, the process is said to be a critical situation. P1 will be requesting R1 and P2 requesting R2. So one process at a time can use one resources. So P1 will be allocated the resource to the requesting. R1 will be resource will allocate to the P1 and P2 have allocated to the R2. At the time R2 will be um, requesting the from resource from R2. P1 requesting resource from R2. So when a process is accessing a shared variable, the process also to be a critical system. One process at time can be used a resource. That causes mutual exclusion. Then hold and wait. The most popular condition hold and wait is printer one is having, printer and scanner is having. Task one we are doing holds printer is holding the task one. The task 1 wants to scan the same process, and the task 2 wants to do the same process in the printer. So process holding at least one resource in a waiting to acquire additional resource held by another process. So printer needs scanned copy to print, and scanner wants to copy a scan. So this type of process causes the hold and wait, causes the deadlock. Then no preemption. yeah, most popular condition, no preemption method. In this condition, the process P1, a resource can be released only voluntarily by the process holding it. After the process has been completed, it's stuck. It will be voluntarily release the process after completing its task. That is the no preemption. Number of resources can be feasibly removed from a process holding it. So no preemption is the thing we having P1, P2, P3, and P4. So P1 have the resource R2, P1 R1, R1 having the resource from P1 P2. So this kind of voluntarily the process holding it after the process can be completed the task. So that's all about this lecture video. We can see in the remaining deadlock condition in the some other video. Thank you. Thanks for watching.